Channel networks, routing. So now that we know how to synchronize payment channels, how do we find actually a path towards a particular peer? So routing is really the problem of what way do we have to take in order to reach a particular target peer. And this is because, let's say we know about this path. It could be that this particular path here, the sub-path between these two nodes, is depleted. If this is depleted, then we need to find another alternative path that we can go through. So we can send this payment here along this path, tuck, 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 and then reach this final node. Note that because you're taking like one more channel, right, in this path compared to this one, the transaction fees will probably also increase. So it's something I haven't mentioned yet, but these peers here, for each channel, they can request a certain amount of fees for routing a payment. So that's a problem of route finding. And if you look at this particular graph here, this is the Lightning network at a given point in time. And the good thing is here that the blockchain keeps a record of which channels are open, right? Because you have the initial transaction that opens the channel, and you have the last transaction that closes the channel. So channels are advertised in an orthogonal peer-to-peer network via a gossip protocol. So if you want to know about the advertisements, you can join this gossip protocol network. So what kind of routing properties do we want to achieve? Well, we have to achieve scalability. So the routing algorithm should remain effective and efficient. We will define those in a bit for large-scale payment channel networks and high transaction rates. High transaction rates means a throughput of many transactions per second. Because every time you perform a transaction, the graph needs to be updated, right? Because on an edge or a payment channel, once you deplete some of the amount in the collateral that is depleted, then you have to push through more coins. So it should be effective. So given the network topology, you want that the routing algorithm should find the path that will likely be successful, right? Because it could also be that the payment is unsuccessful, that it fails, and then you have to restart the payment. It's very annoying. And the routing algorithm should be efficient, so you want that the overhead of the path discovery should be low in terms of communication, latency, and computation. Obviously, you don't want this to be overly complicated. So just to make sure that you've understood, I want to explain again. So if you have a payment channel, let's say this is one part, and we have a payment channel here to this other node, right? If it goes from A to node B, if we deposit here 1 coin, right, and we send 0.5 coins in along the way, then we can only send 0.5 coins here, right? So if there's a second payment, if there's a second payment of 0.5 coins, then this is here updated to 0, right? 0. And this means this path can no longer be used for further payments unless there will be payments done in the other way, or unless A is topping up the collateral here in this particular channel, right? So this is what we refer to when we say the channel is depleted. So, and that's why the routing algorithm here needs to remain effective and efficient for high transaction rates. So when these states are being updated. So there are two main routing approaches. There's the global view and there's the local view. So the global view assumes that the topology is known, right? You have a view of everything, so you know how the topology looks like. And what's typically performed here is the so-called source routing. This means the sender computes the best path during the transfer. Each hop is told the identity of the next hop, right? That's something that Lightning does. In the local view, the topology is not known, so you have a per hop routing, right? So it's per hop. And this means the sender isn't actually computing the best path. It's that every hop is aware of the final destination and they choose the next hop. It's not the sender. Yeah? And this is, for example, a Silent Whispers by Ruiz et al. That was proposed. So what about routing and privacy? Well, you have value privacy and you have transfer privacy. Value privacy is something where when you find a path without revealing the value of the transfer. And transfer privacy is if the sender and receiver privacy should hold, right? So you don't want even though you know how to reach the receiver from the sender, you don't want that their privacy is compromised.